Okay, so Assalamu alaikum. So this is my demo video of PSM2. So first of all, I did my topic is on uh, comparative analysis of machine algorithm based on IoT sensor data for IoT data classification. So first of all, this is my experiment run. So this is my primary experiment run where I import pandas because this is a Python-based language, and then I import train test split. Then I import the panda. Then again I give the dataset which I have chosen. So the dataset is currently looks like this. So there is some zero values and none values in this dataset. So this is the dataset. So after data shaping, we describe the data, and then we describe a plot. So this is the dataset plot for a number of columns, number of rows. Ensure at least 2 columns. For ensuring 2 columns, we use noun function here. For here, we give the figures as 30, and for any to remove any unused subplots, this is the function. And after this, this looks like this. And then numeric data for correlation. This is the correlation matrix, which is to indicate that how the data is centered. So these are the yellow lines, which determines the time. This is the sound max, sound steady. These are the sensors like gasometer, sound sensors, accelerometer, mean, max, and all this. After this, we label the target values, and then this is the data info. There is some null values. So after this, there are some values like bike, bus, car, steel, training, and this is the target. And after this, we train x train and x test, then we train y, then y test, then the train test is split xy, and this is how we will measure the from import accuracy and F1 score. We will measure the primary results of 2 algorithms of random forest. So for random forest, we first of all x train and y train, then we go to testing for accuracy score. So the accuracy score is 0.86, and for gradient boosting classifier, we did estimators with the extent is 200 and the learning rate is 2.3, and we did x train and y train, and the score is 0.90, which is 90%. So these are the graphs. We export some graphs from here. The figure is 10 and 6, and the color is blue and green. So these are the accuracy comparison of random forest and gradient boosting. You can see there is a little bit higher score in the gradient boosting. So this is a part of my primary results. After that, for better results, we pre-process the data set. So this is from, first of all, we load the data set with this, then we fill the missing values. There is some error in this file, so we fix the error later on. So let's go to this. So this is how we import the file. Then we print the initial data. We can see the initial data is this initial data. This is the initial data. This is the initial data. And after this, we separate the numeric and non-numeric values with float 64 and N64 for the columns. For missing value, we use like this. After filling the missing values, display first rows. So the display first rows is this one. Yes. And after this, use forward fill method. Then the standardization or normalization. We use standard scalar function here to fit properly. Display first few rows after standardization. Okay, so data after filling the missing values, this is this, and data after filling non-numeric columns, this is the another. And after for the standardization, after this one, so after the standardization, this looks like this. So it's better for pre-process data to involve the experiment. So we did 3 parts, which is missing values, standardization, and feature selection. So after that, yeah, we give another non-numeric data if necessary, reintegrate the new non-numeric data if necessary. Then we give the target column back if it is non-numeric and was excluded. So and then the finalized data. So we so the data set of the preprocessed data set is CSV. So after that, you can see there is no zero null values data in here. So after preprocessing, it looks like this and standardization. So yes, this is the part of my preprocessed data. So there is no zero values in the preprocessed data. Standardization and feature already made. So this is how we did the pre-processing. After that, we go to the experiment. So for experiment, we go to this where calculate matrices. So we used matrix for accuracy, precision, recall, F1, ROC, and AOC. So these are the display matrices to display in the display here in this. Then after gradient, we did the X-trend, Y-trend. So this is the difference. We did the preprocessed data. After that, we did this. So after the preprocessed data, we import here, load the data here, and we did the same methods of preprocessed data like standardization, filling data values, and this one. After that, data features and target, data scale, drop, x-axis, y-axis. Okay, then we split the data for training and test case. This is the part X-trend, Y-trend, Y-trend, Y-test. So this is how we did. And then the random booster classifier, we take estimators of 100, calculate the matrices for random forest, accuracy score for Y-test, and this one how it looks. Then the gradient boosting estimators we take 200 and learning rate is 0.3, X-trend and Y-trend, and these are the metrics for to show here. And then calculate a data from for the data frame, create a data frame for the matrices. This looks like this, and these are the plots for like bar plots and other bar plots for model precision, model recall, and so on and so forth. So for better visualization, we go here. So these are the results. So random forest matrices and accuracy score. So we can see the accuracy score is 0.88, while the gradient boosting is slightly higher, 0.893. Precision score is 0.88, and while it is a little bit slightly better, 0.889. And you can see this one a little bit better AOC, 0.982. So all we can see the gradient booster is a little bit better. For better understanding, we go to another plot. So these are the plots. This is the confusion matrix for gradient boosting and the random forest. Then these are the scores: 0.88 for accuracy of random forest and 0.893, slightly better. You can see for this green line is the gradient booster, so we can check that the gradient booster is a little bit better in all the matrices. Then we did this is another kind of graph. So you can see the gradient booster is little bit better. Yeah, these are the gradient booster, which is 0.90 and little bit better than the random forest. And then we did for better understanding, these are the met plots using accuracy bar. So accuracy bar has different, precision bar different. The style is white field and full one. And after this one is the 0.885, 0.895 model. Precision is the better for gradient boosting. For recall, it is more better, little bit better, not more better. Both model perform really well. So after this, we did a comparison. Already show that previously. Then these are this confusion matrix for true, negative, true, positive, and for all this the predicted and the actual. We can see the predicted and the actual from here for random forest and gradient booster. This is the kind of heat map, and after these, this is the bar plot with both together. We can see that the random forest is a little bit slow, a little bit less accurate than the gradient boosting. So we choose gradient boosting as best resultant. You can also see in the graph, this graph. This is see a little bit slight difference, slight difference. As this one is almost same. After this, you can see the same here. You can see this is the results. Yeah, this one also line plot. After this, we did the time analysis. Oh, this is the for the pre-processed dataset features of histograms of features for each of the features like time, mean, and all this. After this, there is also line graphs. I think the next result is here for all the sensor density plots. Like here the density is most, like here the density is the most, density here is the data densities. So this is the features after pre-processing. This is the correlation matrix after pre-processing. Okay, so after this one is the final pre-processed data results, and this one, yeah, this one is the same as previous histograms, and this one is awesome, I think. Yeah, so we also did the execution time analysis, which you can see okay, so this is it, and we also did a time analysis. So you can see that model training time here. Model training time here. Okay, so this is the model training time. You can see that the gradient boosting took a little bit more time in training the data, and but for prediction it takes less, because of I think the gradient boosting is most accurate. It takes a little bit time more in training, but it takes less time in prediction. So overall the GBC we can see it's better to form all these things. So I think that's it for my results views. I think the gradient boosting is much better. Not much, it's like both model performed really well in terms of this. So that's it. Thank you so much. This is for my demo video.